So good morning everyone. So in our last class, we studied the concept of functional dependencies. So a functional dependency uh, is denoted by X arrow mark Y, where X is one set of attributes and Y is another set of attributes of a relation. So within a single table, so this is a within a single table, so we can divide this into two sets of attributes, where one set of attributes will uniquely determine the values of another set of attributes. So just like your USN will uniquely determine the name. So which means for a given USN there will be a mapping to a name. So this is the fundamental for uh, normalizing a database. So if you understand the concept of functional dependency, then we will understand the concept of normalization. So functional dependency is when a set of attributes uniquely determines the values of another set of attributes. So next we shall study the normalization of relations, its practical uses by defining the various types of keys and attributes that are participating in a key, and later on we will discuss first, second and third normal forms. So normalization is a process of decomposing unsatisfactory bad relations by breaking up their attributes into smaller relations. So which means if we have a single table, then we will divide it into multiple tables. So that is the process of normalization. And when we will break it, when it violates some rules. So what are those rules? So that depends on the normal forms. So a normal form is a condition which is defined using the key and a functional dependency of a relation to certify whether a relational schema is in a particular normal form or not. So normal form is nothing but a rule. So if that rule is satisfied, then we say it is following the normal form. So for example, we will start with defining the rules in the first normal form. So we also call it as 1NF. So 1NF means first normal form. So this has some rules. Okay. So if our relation obeys this rule, then we will say our relation is in the first normal form. Then if it obeys the first NF, first NF rules plus 2NF rules, so 2NF rules we have, then we'll call it as it is in 2NF. So the relation is in second normal form. So which means 1NF is the base rules. If it follows the basic rules, then we call it as first NF. If it follows basic rules plus the rules of second level, then we call it as it is in second normal form. Then if it follows the second normal form plus additional rules of third normal form. If it follows, then we say the relation is in third normal form. So if a relation is in third normal form, it indicates that it is obeying the rules of first normal form and it is also obeying the rules of second normal form. So it is additional level of rules. Then if a relation is in third normal form plus it obeys some additional rules, so that we call it as BCNF, Boyce Code Normal Form. So Boyce Code is the name of the database scientist. So if it follows that, then we say that the relation is in BCNF. Okay. Then on top of this, we have two more levels. So that is BCNF plus some additional rules that will lead to fourth normal form. Then fourth normal form, our relation is satisfying, plus some additional rules, then we will say it is in fifth normal form. And fifth normal form is the highest level of normal form. So if we represent it in a hierarchical form, then we will have one NF over here, on top of it second normal form, then third normal form, then BCNF, then we will have fourth normal form, then we will have fifth normal form. Okay, so for a standard relation to implement it, we expect it to be at least in the third normal form. Okay, so third normal form is the standard one. At least our relation should follow or should obey the rules of third normal form. And on top of it, these are the advanced rules. So first normal form is defined based on how we create a table. So that is inbuilt into the definition of a relation. Okay, then second, third, and BCNF are defined based on the functional dependency and the keys of a relational schema, whereas fourth normal form is based on key and multi-valued dependencies, and fifth normal form is defined based on a key and join dependencies. So additional properties may be needed to ensure a good relational design, that is the lossless join and dependency preservation. So a set of functional dependencies is given for each relation, and that each relation has a designated primary key. So this information is combined with some tests or condition, we call it as rules, for normal form, and the process in which we put our relation to test, and if it fails a test, we will modify the relation. So modification is nothing but we will divide the table into multiple things. So that process we call it as normalization. So normalization is a process of refining the relational schema in order to make it obey to the rules of the normal forms. So most practical relational designs will follow one of the two approaches. So first is we will perform the conceptual schema design using the conceptual model, such as the entity relational model or extended entity relational, and then we will map it into a set of relation, which means first we design the ER diagram, and from the ER diagram or entity relation diagram we will map it into tables. Or what we do is we'll design the tables based on the external knowledge we have from the existing implementation. So in either two ways we can design the tables. So normalization of a relation, what we do is we take a relation schema, or we'll take a table, and then that table is subjected to series of tests. So for certification, if it satisfies the test, or if it passes through the test, then we will apply one more level of test. If it passes it, then one more level of test. So like that we will keep on testing the relational schema. If it fails any test, then we will also have another, we will have to conduct a procedure in order to bring it to the level we want. If it fails the second normal form test, then what to do? So that we will study when we will be studying at different levels of normal forms. So we will bring back our relation into the normal form, to the respective normal form. Once we bring back, then we will again apply the higher level of tests. So initially, Cod is a scientist who proposed three normal forms. So first, second, and third normal form. A stronger definition of a third normal form is added. So that normal form, it is called as Boyce code normal form. Okay. So it was later proposed by the database scientist Boyce and Cod. So all these normal forms are based on a single analytical tool. That is, it depends on functional dependency and the attributes of a relation. Whereas fourth and fifth normal forms were proposed very later. So depending on the multi-value dependencies and the joint dependencies. So normalization of data can be considered as a process of analyzing the given relational schema based on their functional dependencies and primary keys to achieve the desirable properties of minimizing the redundancy and minimizing the insertion, deletion, and updation anomalies. So our sole intention of applying the normal form rules is to minimize the redundancy. So in yesterday's class, we studied redundancy. So redundancy means same information is stored at a multiple locations. If same information is stored in multiple locations, then storage will grow. Not just that, if you want to update anything, it has to be done in all the places. So that is the effect of redundancy. So that we want to bring it down. And secondly, we want to minimize the anomalies. So we saw yesterday the different examples of insertion, deletion, and update anomalies. So we can also consider normalization as a filtering or purification process to make design have a better quality. So a formal framework for analyzing a relational schema based on their keys and functional dependency along with the attributes is used to bring it. So any table which satisfies the highest normal form, so that is the normal form we call it. For example, a table is, we will say it is in 3NF if it obeys the rule of 3NF. We will say it is in BCNF if it obeys the rule of BCNF. So for a relation to obey BCNF, it automatically has to obey 1NF, 2NF, 3NF, and BCNF. So the highest level of normal form it satisfies. So we will use that normal form to say that our relation is in this particular normal form. So the two properties we must include, that is the lossless join. So lossless join, it guarantees that the spurious tuple generation doesn't occur with respect to the relational schemas created after decomposition. So lossless join, if we decompose the table, means if we divide the table during the process of normalization, then in running the queries, if you want to again join those two tables, then it must guarantee that spurious tuples will not be generated. So spurious tuple is nothing but a tuple that doesn't obey the rules of the application. So we cannot join two students based on their sections. So the joining should happen based on the primary key, that is the USN. So if we join two students, two entities in a different table based on a section, then there is no guarantee that the same USN is joined together. Again, the second property that the normalization should follow is the dependency preservation property. So this ensures that each functional dependency represented in a relation is maintained after the decomposition. So that also should be taken care. So when we divide a table, two things should be taken care of. One is it should be lossless. Another thing should be dependency must be preserved. So dependency means it is the functional dependency. So all these concepts, whatever we are discussing from yesterday's class, these are all the advanced concepts. So which means that needs the greater care and attention. So practical uses of normal form. So normalization is carried out in practice so that the resulting design what we do is of high quality and it meets the desirable properties. So the property that is desirable is the redundancy and the generation of spurious tuples and affecting the anomalies. So the practical utility of these normal form becomes questionable when the constraints on which they are based are hard to understand or even hard to detect. Again, it depends on the application we are building and how much domain knowledge we have on it. So the database designer need not normalize to highest possible normal form. So that's what I told in the beginning. So we don't want it to be at the fifth normal form. So the designer possibly we want it to be in 3NF or BCNF is also okay, or 4NF. So it is not mandatory to get it to a fifth normal form. So even if it is in third normal form, it's okay that designers can go through. And all the other things, the rules that we apply in BCNF, 4NF, or in 5NF, that can be taken care by the middle tier. So normalization is one process. So the reverse of normalization is also there. So that we call it as denormalization. So denormalization is a process of storing the join of higher normal form relations as a base relation, which is in lower normal form. So normalization generally, if it fails any test, will divide the table. So it is a division of the table. If we do the reverse of it, means we'll join the table. When we join, it fails the tests. It will go down to some lower normal form. So that process is called as denormalization. So denormalization is also done in few of the cases when required. So all these normal forms, they depend on the definition of a key and attributes that are participating in a key. So we have several terms that we need to understand before moving further. So those terms include the first term that we want to understand thoroughly is the concept of super key. Then we need to understand what is a key. Then we have to understand what is a candidate key. And then finally, we need to understand primary key. Okay, so it is primary key that which we have used it in creation of all the tables in our laboratory experiments. But in order to decide which is a primary key, we have to go through all these concepts. So first is super key, second key, then candidate key, and fourth is the primary key. And there is a difference between these four terms. So half of the database concepts will be clear if we understand the difference between these four. So we shall look into these four concepts. Only once we understand these four, then only it is possible for us to move on and discuss the various normal forms. So first, it is a super key. So the definition of super key is a super key of a relation schema R is a set of attributes. Yes, it is a subset of R with a property that no two tuples in any legal state will have a same value. So by looking at this definition, we may not understand what it is. In order to understand that, let us consider an example of a student relation. So with very minimum attributes, we will start. So let us assume a student is having USN name, okay, mobile, mobile number, and semester. So let us just consider these four attributes. So for these four attributes, so we must understand, or we must obtain a super key. So what is super key? Super key is a set of attributes. So how many attributes are there in this particular table? There are four attributes. So which are those? USN, name, mobile, and semester. So these four attributes are there. Then for this table, we must identify its super key. So what is super key? Super key is a set. So from this four attributes, how many sets we can make? So that is a question. So for a given four attributes, so we can have 2 power 4 subsets, right? So mathematically 2 power 4 subsets are possible. So one with all the four, then three different combinations of three is possible, then with two attributes, then with single attribute. So that is a possible one. So next, what are the different possible subsets? So we will try to list. So one is the USN, so one attribute, then name, okay, then mobile, then semester. So single attribute. So these four is the first possibility. So second possibility is including two attributes. So USN, name, USN, mobile. So similarly USN and semester. USN, semester. So again, if we start with name, so I will just write the short forms. N and M, that is name and mobile. Yeah, before that name and USN. So name and USN is already present over there. So name and semester. Okay. Then if we consider mobile, so mobile and name is already there. So mobile and USN is also there. So we are left with mobile and semester. So two attributes, another set. Next three. If we consider three, then we will have USN, name, mobile, then name, mobile, semester, then another one USN, mobile, semester. So another one would be USN, name, and semester. So four possible things. Our last set would be so USN, name, mobile, and semester. So all the four are included. So and we will not consider the a null set. Okay. So now out of this, now when we have listed all the possible sets, now we will go back and apply the definition. So super key is a subset set of attributes, yes, that is subset of R with a property that no two tuples in any legal state will have a same value for tuple of S1 is equal to T2 of S. So what is the meaning of it? No two students should have the same value for a super key. So then we'll apply it one by one. Can two students have the same USN? No, which means this can be used as a super key. So USN can be super key because no two students can have a same value for USN. Then name. Can two students have a same name? Yes. So which means this cannot be used as a super key because two students can have a same name. Then can two students have a same mobile number? So that is also not possible. So two students cannot have same mobile number. Then can two students have a same semester? Yeah, here yeah, mobile has to be ticked because two students cannot have same mobile number. Then moving on, can two students have a same semester, can be of same semester? Yes. So if the answer is yes, then it cannot be a super key, because in any legal state that should not happen. No two tuples. So two students cannot have same USN, so it can become super key. Two students cannot have same mobile number, so it can become super key. Next will come, can two students have a same combination of USN comma name? USN is also same, name is also same for two students. Is it possible? So it is not possible, right? Because USN obviously has to be unique. So USN and name has, obviously it has to be different. So it is again a competitor for super key. Then can two students have a same value of USN and mobile? So here this indicates USN is also same, mobile number is also same for a student. So is it possible? No, it is not possible. So if it is not possible means it is a candidate for super key. Then two students, same value of USN and semester. Is it possible? Semester can be same, but USN cannot be same. So which means their entire combination cannot be same for two students. So if it cannot be same for two students, then it is a contender for super key. Then on the other side, so again name and USN, it is already over. Uh, the combination of name and mobile number. Can two students have same name and same mobile number? So that is not possible because mobile number has to be different. So if mobile number has to be different, then obviously that is a candidate for super key. Then can two students have a same name and same semester? We can have a student with the same name in the same semester, that is possible, which means this is not a candidate for super key, right? So this is not a candidate because the two students can have same name in a same semester also. Next, can two students have a same mobile number and same semester? So that is not possible because mobile number has to be different. So the combination has to be different. So if it has to be different, then it has to be a candidate for super key. Then, so this completes two sets. Now let us go to three attributes. So can two students have a same USN, same name and same mobile number? So that is not possible because either USN has to be different or mobile number has to be different. So if it is not possible, then it is also, this is a candidate for super key. Then can two students have same name, same mobile number, same semester? So name and semester can be same, but mobile number has to be different. So which means two students cannot have the same combination of name, mobile number and semester. So which means it is a candidate for super key. Then USN, mobile and semester. So USN is there, mobile is there. So two students cannot have same USN, mobile number and semester. So if they cannot have, then it is a candidate for super key. Then can two students have same USN, same name and same semester? Is it possible? No, because USN has to be different. So it is a candidate for super key. Then USN, name, mobile number and semester, all four are same for a student. Is it possible? So it is not possible because USN has to be different, mobile number has to be different. So two students cannot have all the four values same. So if it is not possible, then it is also a candidate for super key. So we listed the all the possible subsets, and then we decided which is allowed and which is not allowed. So all of them which have been ticked are all of them are super keys. So a super key is a subset of attributes with a property that no two tuples or rows can have same value for these attributes. So that is, so out of how many subsets we have listed? 4, here 3, 7, 10, 13 and 15. So 15 subsets we have listed. So out of 15, whatever we have ticked, they are all super keys. So whatever is ticked, it is a super key. Now, so that is the first definition, that the concept that has to be cleared for you. Now, next, let us look at the definition of a key. A key K is a super key with additional property that removal of any attribute from K will cause K not to be a super key anymore. So the meaning of this is, from these super keys, so whatever we have ticked, if we remove one attribute from that set will no longer become a super key. So if that is there, then that we will call it as a key. So the definition of key can be applied only if we know the super keys, and it is applied on the super keys. And now we have already listed the super keys. Now let us go back and apply the rules of key. So USN, so it is a single. So, and we will apply this only for those which we have ticked. So USN, only one attribute and it is a super key, so it will obviously be key also. Then name, it is already cross marked, so leave it. So mobile number, it is only one attribute, so that is ticked, so it is a candidate. We cannot remove. If only one element is there in a set, if we remove it, then it will become null set. So obviously that is a null set cannot be a key, so this is a key. Now here, so we have two attributes, USN and name. If we remove USN, right? If we remove USN, will it remain a super key? So that depends on the remaining set whether it is a super key or not. So what is the if we remove USN, the remaining element is name. Whether name is a super key, so here name we have already crossed it out, right? So we have already crossed it out. So then if we remove name, will it remain super key? So if we remove name, we are left with USN. Is USN a super key? Yes, it is a key. Then if we remove one attribute from this particular super key, it is still a super key, which means this cannot be a key. If we remove any attribute from a super key, that should no longer remain a super key. So if we remove name, we are left with USN, and USN is a super key. So this is not a candidate for key. Next, here, consider this, USN and mobile. Now, if I remove USN, we are left with mobile. Is mobile a super key? Yes. Next, if we remove mobile, we are left with USN. Is USN a super key? Yes. Which means even though we are removing the attributes, it is still staying as a super key. So this also cannot be a key. Next, consider USN and semester. If I remove USN, is it remaining a super key? No, because semester is not a super key. But if we remove semester, Will it remain a super key? Yes, because it is left with USN and USN is a super key. So this can not also be a candidate for a key. So we have crossed it out. Then on the other side, yeah, name and mobile number. So name and mobile number. If I remove name, we are left with mobile. Is mobile a super key? Yes, because mobile is ticked over here. So this cannot be a candidate for key. Then yes, this one. Mobile and semester. So if we remove semester, we are left with mobile, and mobile is a super key. So this cannot be a key. Then USN, name, mobile. If I remove USN, is it a super key? Yes, because name and mobile is a super key in the previous step. So this cannot be there. If we remove name, we are left with USN and USN and mobile is a super key. So this also cannot be a key. Name, mobile, semester. If I remove name, still it remains a super key because mobile is a super key. Then if I remove semester, then still it remains a super key. So this again is not a key. USN mobile semester. So if I remove semester, still it remains a super key because USN and mobile combination is a super key. So this is also not a key. Then USN name semester. Again, if I remove name or if I remove semester, it is going to remain a super key because USN is a super key. Okay. So this is a no. Then last one, all the four attributes: USN, name, mobile number, and semester. All the four. We can remove name, it still remains super key. We can remove semester, it can still remain a super key, which means even though we remove two attributes, it is still going to remain a super key. So this is also not a key. So if you now look at, everything is cross marked except two, that is the USN and. So that is the two things, that is USN over here and mobile number over here. So only two sets are the keys. So that is the difference between a super key and a key. So now which are the key of this particular relation? So the key, it is two keys we have, one with USN, so another with mobile. So two keys are possible for this particular table. So for any given relation, so you have to identify the super key first, then you keep on deleting an attribute and check whether it is still going to be a super key or not. So if it is still going to be a super key, then that cannot be a contender for key. Okay. So that is the difference between a super key and a key. So we'll continue our discussion in the next class, where we'll discuss candidate key and primary key. Okay. So you can put your attendance in the chat.